Now this question is looking at bond energies to help us work out a question. The student doing an experiment has burnt octane and found that it gives off a lot more energy than ethanol. Now he thinks that's, or she thinks that's, because it's a bigger molecule and that there are more chemical bonds to break and hence more energy is released. Now we're asked to look at these misconceptions and use the data to back up what we're saying. Now, first of all, immediately when we look at what the student's saying, the chemical bonds to break, when we do these reactions, breaking bonds is an endothermic process, so that absorbs energy, takes energy in from the surroundings to do that. When bonds are formed, energy is given out, it's released, and whether a reaction is exothermic or endothermic is based on the difference between those two. So if an energy reaction only takes in a small amount of energy when it breaks bonds and gives out a large amount of energy when it forms bonds, that's going to be a exothermic reaction where it's releasing energy into the surroundings. And so obviously the amount of energy given off is really to do with the difference between those two factors. The amount of energy it needs to absorb and the amount of energy that's given off when bonds are formed, and you'd be discussing that when you talked about this misconception. And obviously if it's endothermic, it would be because it's absorbing a lot of energy, which is what this student's suggesting, and then if it's only releasing a small amount of energy when it forms bonds, that would make it probably endothermic. Now you would address that as being what the student is saying, which is obviously wrong, which would mean that you would not be actually giving out energy at all. It would be taking in energy from its surroundings. But to show this, we'd first of all do some calculations, and to do that we need to balance some equations. Now if we look at octane and ethanol, we'll look at how to go about balancing those kind of quickly. Now the first thing to do is look at the carbons. Now there's 8 carbons with octane, so immediately we put 8 over here. We see that there are 18 hydrogens here, so immediately we put 9 here, because 9 2s are 18. And then we've got 16 oxygens plus 9, that's 25, so that's 12 and a half oxygens on this side. Got 2 carbons here, so immediately we put 2 here. We've got 6 hydrogens, so immediately we put 3 there. That means we've got 7 oxygens on that side, but we've got 1 here, so we've only got to put a 3 there, and those are now balanced. Now we've got to go through the process of actually calculating the overall enthalpy for the reaction, and once we've done that, we've been given the grams per mole, and that's as soon as we worked out the energy for, say, the octane reaction here, we can use that to work out how much energy per gram just by dividing whatever energy we get here by the molar mass, and that'll tell us how much per gram is giving off for octane, and we can do the same for ethanol. Okay, now let's have a go through that process. Now I've just written this out. Now it's probably a good idea to, I've just done this very briefly in terms of just trying to make sure that I count everything right in octane. You could try and work it out in your head, but it's just a good idea to avoid a simple mistake of not including a bond. Obviously carbon dioxide is a double bond on either side of that, so we'll have 7 carbon-carbon bonds between the carbons. Those are the ones that are often missed out. 18 CH bonds, 12.5 O2 bonds. And remember with bond enthalpies, it's reactants minus products. So I've got 16 carbonyl bonds there, COO, and 18 OH bonds. And if we replace that with numbers as we've done down here, and then we do the subtraction, we get minus 509 kilojoules per mole. Now at this stage, all we have to do is then divide that by, see, this is 114, and that will give us how much energy per gram, and that's going to be 44.7 kilojoules per gram. So that's a minus, obviously, because it's giving off that energy. Now we'll have a look at ethanol and see what we get for that. Now if we write out the formula for this again, we're going to find that we've got one that's often missed as a C double bond O or the CC bond, so just make sure you get that. Now it's reactants minus products again, and obviously if you want to, you could cancel one of those with one of those and make this 5, but it's really up to you whether you do that. You may want to show the fact that you've included that, but it doesn't really matter. They can cancel if they're exactly the same. Now if we go through and replace that with numbers, you'll end up with an overall minus 1263 kilojoules per mole, and if you then divide that by 46.1, I'll just get rid of that. That's and you're just trying to see how much is per gram, and that should give you a number in the region of 24.5. So that's again a minus 24.5 kilojoules per mole. Now, considering that, obviously, and you need to make a statement about this, the one that gives off the most energy per gram is octane, so it does give off the most energy, but his misconception is thinking about the fact that its bonds being broken. That's the main factor. It's a difference between those two, so the more energy that's given off when bonds are formed, the bigger that difference, the more energy is going to be released. So it's the difference between those two that you have to stress. Okay, and that's that one answered.